بسم الله الرحمن الرحيم رب زدني علما.
So next thing, when it comes to routing, let's start with the EIGRP routing. If you are implementing phase 3 with EIGRP, so basically with EIGRP we'll be adding these two commands. Any protocol, we generally add these two commands. So let me just first verify we do have EIGRP here or not. So if I check my routers, these routers are already pre-configured with EIGRP here. Okay, so here I'm going to implement the phase 3, but I didn't change the configuration to phase 3. It's the same phase 2 configurations. And let me just confirm we do have EIGRP here. So if I say show run section EIGRP, based on the previous lab, we did phase 2. It's the same configurations. Okay. So if I try to see here, the configuration is still the same. So EIGRP is already configured. So if I verify the neighborship, so I'm expecting the neighborship should come up. And if you verify the routes, so I'm able to see the routes. So the first thing what we need to do is we need to make sure that we disable the split horizon rule. Again, the same like in all the phases. If I'm using EIGRP, we need to make sure that we disable the split horizon rule. So this is something we need to do in the phase 1, phase 2, as well as the same thing applicable in the phase 3 as well. So let's go and disable this. No IP split horizon EIGRP 100. So once I disable the split horizon rule, what I should see is I should see the spoke will be receiving the routes. Like in the case of router 2, I'm able to see the 3 dot network and the 4 dot network. They are coming via 10.001. So in the phase 3, this is what we want. We want to ensure that in the routing table, the next hop address to reach all the routes or all the spokes, it should be via router 1. So we are not going to change. Unlike in the phase 2, if you remember, we have used no IP next hop self command to change this behavior so that spoke to spoke direct communication can happen. But here the problem is, if I try to trace to router 4 or router 3, you can see the communication is still going via hub. This is purely because of the routing table in general. So in the phase 3, what we'll be doing is we are going to add one additional configuration command. We did this already. We did this. We are going to add IP NHRP redirect on the hub router, and on the spokes we'll be adding IP NHRP shortcut command. Now once we add this NHRP redirect command, so if you see these two configuration commands, you need to understand we are configuring phase 3. So if these commands are missing, then you have to understand it's a phase 2. So that's the only simple configuration difference between the phase 2 and the phase 3. Now what this command will do is, this command is going to send out a message to router 2 saying that if you want to go to 3 dot network, you can reach it via 10.003. That's actually the next hop, and of course the public IP will be 35.003. So it's going to send out a message to the spoke saying that you have a better route to reach the destination spoke instead of going via hub. So basically that's what it's going to indicate. So whereas if you're using IP NHRP shortcut command, now this shortcut command is going to install this particular route. Basically in the FIB table, it's going to add the alternate route. So basically it is going to change the best route. So that's what here you can see. NHRP redirect is a special message which is being sent by the hub. So it's going to tell that there is a better path to reach the remote spoke again. Okay. So all it does is it enforces the spoke to use a resolution request for the specific IP destination. Whereas if you're using NHRP shortcut command, it is going to override the safe entry, because by default, as per the routing table, to reach the 3 dot network, you have to go via 10.001. That's what you have in the routing table, as per the routing table, but it's going to force, this command is going to force to write the safe entries, because normally the forwarding happens based on the safe. to use the direct spoke instead of going via hub. So let me just quickly add this command and verify the change in the behavior of the spokes here. So let's go and add interface tunnel 0. I'm going to say IP NHRP redirect, and on the spokes I'm going to add IP NHRP shortcut. So let me quickly add the same thing, IP NHRP shortcut, and likewise on the router 4 as well, IP NHRP shortcut. So now let's try to verify here. If I say show IP route EIGRP, you can see the routing table is still, it shows the same thing. So I'll try to trace, so you can see. So initially it still goes via hub, and later on it will again fall back to the direct spoke to spoke. And if you try to check the routing table entries, still it shows the routes are pointing to router 1, that is router 1. But you can see this entry, the change in the entry, it says this is actually changed by NHRP. That's what this symbol actually indicates. Okay, so the next hop override, it's a kind of next hop override which is changed by the NHRP protocol based on the NHRP redirect messages which are sent by the hub. So typically if you try to test the same thing with 4.4 as well, initially it goes via 1.4, but later on it changes. And if you verify the routing table, you can see, so even if you verify the CEF table, basically I think this is how you can check. The next hop it shows router 4 here. But basically the next hop as per the routing table is router 1, but it actually overrides with router 4. That's what the shortcut command will do. It tells the router 2 or the spoke router to override the CEF entry to the next hop, which is generally generated here. Okay, so this is what phase 3. So similar way, let me try to verify the same thing here from 4 to 2. So if I say show IP route EIGRP, you can see the routing table still points towards the router 1, which allows you to summarize the routes. That's a good thing. At the same time, you can still communicate to 2.network directly via spoke to spoke, as you don't need to go through the hub again.